Hi everyone, my name is Arun Punia and welcome to this OCI Network Firewall workshop. Recently we published one of the OCI Network Firewall workshop on our Live Labs platform. So today we're going to focus on this workshop outline and what are the different key features are associated with it. You can follow the workshop to deploy the resources using Oracle Resource Manager, which is a Terraform, or you can deploy the resources manually by following the instruction. You can learn how to deploy network firewall, how to update the required policy to support your use case. We're going to focus on some key features associated with our architecture. Some of the key features which we're going to focus are also supported from OCI Network Firewall are stateful network filtering, custom URL filtering, IPS and IDS, SSL inspection, how you can enable the traffic or threat logs, how you can monitor the metrics associated with network firewall, as well as how you can do intra-VCN or inter-VCN traffic inspection. So before we jump on the workshop, let's take a quick look on our architecture. So there are two ways you can deploy OCI Network Firewall. One is in like distributed model, where you have firewall sitting into each VCN. Another one is transit model, where firewall is sitting like an hub and spoke architecture, where you can connect from spoke to hub through some kind of a gateway, like dynamic routing gateway, which is recommended. So in this workshop, we're going to focus on transit model, which is hub and spoke architecture. So our architecture is like this. You have firewall, which is sitting into one of AD. As you know, firewall is an AD specific entity. So make sure that you understand and consider that during your architecture deployment. In our case, firewall VCN is acting as a hub VCN. Then we have a spoke VCN, which has a couple of subnet, as well as firewall VCN has a couple of subnet like client and server. Spoke VCN is attached to firewall VCN through DRZ. We are also going to explore ingress routing capability and intra-VCN routing. As you know, OCI supports inter-VCN routing as well as intra-VCN. Inter-VCN will be done through the DRZ and the VCN attachment and the VCN ingress route table. Intra-VCN, we're going to define the subnet level route table entries to make sure the traffic goes to the firewall. So let's quickly jump on OCI Network Firewall workshop outline, how you can see it from Live Lab. Alright, so to understand OCI Network Firewall, you can go to Live Lab platform. You search for OCI Network Firewall workshop here. This is publicly available. You should be able to access it and understand how you can deploy network firewall and get yourself familiar with the solution. So if you click on the workshop outline, it talks about the solution, different architecture, the architecture which we are going to deploy. Ideally, we're going to deploy two VCN, firewall VCN, spoke VCN, VMs, and required subnet, and firewall. There are some prerequisites. You need to have an OCI tenancy. You must have required permission and resources quota to deploy the resources as per the topology. Once you have those prerequisites met, you can follow this workshop outline from onwards. For example, the outline is pretty straightforward, easy to follow. The first one is like how if you don't have an account, how you can set up an account of OCI. Hypothetically, suppose if you have an account, the idea would be how you can deploy the resources. The first, you can deploy the resources using Oracle Resource Manager, which is like an automation, Terraform automation, which you can follow along, or you can follow manual instruction. If you are using Oracle Resource Manager, you need to follow the lab 0, but if you are using manually, you can skip this lab 0 and continue from lab 1 onwards. Let me just quickly show you lab 0. Click on expand all tasks, download this file. This is zip file, which will download the Terraform code locally. Once you deploy once you upload the Terraform zip file using Oracle Resource Manager and the instruction provided here, you can choose like create new VCN and subnet. But if you choose to modify, you can modify the code as per your need. In our case, we're going to keep it simple. So once the Terraform plan is successful and apply is also successful, which takes 30 to 35 minutes. The reason is firewall deployment takes some time. You would be able to see there are a couple of VMs are created successfully on OCI tenancy in a compartment, as well as network firewall is also created successfully. So before we jump on the validation on architecture, let me just quickly show you, if you are curious to know, lab 1 and lab 2 are nothing but about manual instruction which you can follow along to deploy network firewall VCN, spoke VCN, create required dynamic routing gateway attachment and route table entry on each VCN, launching a VM into firewall VCN, as well as spoke VCN which you can follow along. Once that is successful, you'll be able to see those VM. At the same time, in lab 2, if you are following the manual instruction, you need to do that. The first step is you create a required network firewall policy, which you will also show, but as an outline, you can follow along this instruction. Once the policy is created successfully, you will be using this policy to create a network firewall in your firewall VCN. As I mentioned, network firewall is an AD specific entity attached to a subnet. So you attach that to your firewall VCN subnet. Once the firewall is successfully completed, there are a couple of instructions which I provided to update the route table entry, which you need to follow if you're doing manual instruction. Once everything is configured successfully, you can jump to lab 3. That's where we're going to focus on this workshop to talk about different ways of supporting key feature and creating required policy for that. At the same time, we're going to focus on lab 4, which is about traffic validation. In our case, what we have done here, I'm using Terraform stack to deploy the required resources. So my plan and apply are successfully completed. I have the VM sitting into firewall VCN, client and server as per our topology. I have server B and server A also sitting into spoke VCN. These are nothing in my compartment, firewall VCN, spoke VCN. If you are curious to know what the spoke VCN subnets are, you can click on that. Same goes to firewall VCN. I have a server subnet, client subnet, and firewall subnet. In my case, I'm deploying firewall into a public subnet because I want to protect the public workload, which is like a client VM on public subnet. If you are trying to protect private and public workload, you need to make sure that firewall is deployed into public for public workload, and it's just for only private workload, you can deploy firewall into private subnet. Same goes for spoke VCN. I have 2 server subnet, and which are one is in public. The reason is because I want to connect from outside, and one other is a private. So that way, idea would be we're going to do inter VCN as well as inter VCN traffic inspection. My network firewall is already running into my compartment. It's available under identity and security. So as you know, it's attached to firewall VCN and firewall subnet. So the only end user we're gonna see is the firewall, is this firewall IPs are exposed here. So let me just go back to my lab 3. So that's where we're gonna start following how you can create a policy. If a policy is defined the first time, that's fine. Otherwise, how you can clone it and go from there. All right. So assuming at this time, end user who are following this video must have deployed the required resources either using lab 0, which is an automation, or lab 1, 2, which are manual instruction. So your firewall should be up and running along with the required policy, which is the policy's demo policy, which we created the first time. This is nothing but allowing all rules. And then this policy is attached to your network firewall. In my case, and the policy, I have modified the policy, which you're going to see in a bit, what the policy looks like. So currently, if your firewall is running, you would see this a policy attached to it. If you want to modify the policy, you would have to clone this policy. So click on clone policy. Enter the name which you can refer. Click on next. These are the application list which I am currently have. So if you are following the lab 3 instruction, so as you see the first part, it talks about how you can clone the policy. You click click on the clone policy icon. Once the policy is cloned, you can add the required application list. In my case, to save some time, I have already created an application. So in my case, ICMP list has an echo code for 0 and 8. Same goes for HTTP and HTTPS and SSH. I have port range 22 and 8080 and 443. You can edit them. So in my case, an HTTPS here. You can add additional application up to 25 using a port and protocol which are supported. Or you can create a new application list if you choose to. And based on that, you can enter those values, what's the data point which you want to enter. Similarly, you can add an URL list. In my case, there are two URL. One is info7.cs or espn.com. You can modify them because the reason is I'm going to use one for HTTPS URL filtering, one for HTTPS for espn.com. But if you can add multiple URL lists, you can follow along the official document to know more about what kind of the URL wildcard and all which you can enter. Similarly, you can add additional address lists. In my case, as per the required architecture, I have entered client-sider, server-sider, web subnet A-sider, web subnet B-sider. So I have a client-sider which you see here, my public IP that's the public IP I'm going to connect from outside to make sure that I am the only one who can connect to the client VM public IP. Server-sider, server A-sider and server B-sider, and some of the spoke VCN subnet, including the server A and server B both. I have already created required SSL script. So SSL inspection I need to have. If you follow along this workshop, these are the URL lists which we have just looked at it. These are the IP address lists which we just looked at now, which you need to create. Then you need to create a map secret and decryption profile. To create a map secret and decryption profile, there are some prerequisites. So you need to make sure you create a vault, create a secret, and a secret is nothing but a certificate, and you store that certificate into your vault. So you can follow these instructions to know more about and all. But if you are curious to know what I've done here on my Linux VM, I download this script which is available in this quick start. This script, I'm going to use SSL forward proxy. So you need to pass the script as shell script with the forward parameter and the firewall IP. In my case, the firewall IP was 10.10.0165. Once you file that IP, it created an SSL forward proxy certificate, the JSON file, which you need to enter into your secret under your vault. At the same time, you need to update your local VM. Make sure that you add this forward proxy certificate in your CA trust. Once you do that, you can follow this network firewall map secret. So this is that map secret. If you click here, this is the map secret which I did. So it's pointing to my vault, and this is my secret here. Then you create a decryption profile. This decryption profile is nothing but SSL forward proxy is using SSL forward proxy point. Then you need to create decryption rule. Decryption rule is which I'm gonna using SSL forward proxy. The idea here would be client IP, if it wants to talk to anything outside over SSL, it should use the certificate which I'm using for SSL forward proxy. So I'm going to decrypt with the SSL forward proxy, my profile, and the map secret. There are many various rules which I have created here, but if you are following the workshop, you can understand those rules here. This is the decryption rule which we looked. These are the security rules. So there are many security rules which we're going to follow along to support our use case in lab 4, but which are pretty detailed here. So ideally it was pretty easy to do so. You can create an add security rule, put the name here, select your source like client-sider or subnet-sider where it needs to go. Choose your port or protocol. In my case, if I'm choosing UDP TCP, I will see this my list here. I'm going to choose an ICMP. I'm going to see them. Choose my URL. If I'm going to choose a specific to TCP UDP, I will be able to see my URL list. And then you can allow traffic, drop traffic, or reject traffic. If you are choosing an IDS, you choose intrusion detection. If you're choosing IPS, you choose intrusion prevention. I'm not going to go into each rule. The reason is because it's already documented. What you can do, you can follow along. These are the different rules which I already created here, and these rules are associated to this policy. And in the end, I'm using a drop rule to make sure that it's hitting that rule, not the default drop rule. So once you create those prerequisite configuration like application list, URL list, IP address list, decryption profile based on your map secret and decryption profile, decryption rule, and security rules. Once you've done everything here, you can create a policy here, and this policy will be cloned with the name of the clone policy here. In my case, there is no difference between this policy and top. The reason is because I already had the same configuration. But if in your case, if you are using the following the workshop, you would have to apply this new clone policy to the firewall. So click on network firewall, click on the firewall here, click on edit, and choose your network firewall clone policy here. Once you do that, it will take some time, like a couple of minutes, to make sure that this clone policy is applied successfully. You would be able to track those requests from your work request here. This is the update firewall. You would be able to understand each work request, what are the logs are following. If there are any error messages, you can follow along what was the reason of policy failure and all. In my case, network firewall policy already had the required policy as per the lab 3. So if you follow along lab 3, we created the updated the policy. How you can enable the traffic log or threat logs. So go to network firewall, click on logs icon here. This is the simple toggle button. You can choose existing log group or log name, or you can create a new one depending on what you want to do. And there are a couple of metrics which you can follow along. So these metrics are nothing but are associated to different policy, which you will see in a bit in a lab 4 exercise. And understand them much more better, how you can follow along. Alright, so now at this point we have completed lab 3. Now we're gonna move to the lab 4. Lab 4, that's where it talks about different security feature associated with the network firewall. For example, we're gonna test out north to south inbound, outbound, intra-VCN traffic, inter-VCN traffic, IPS IDS, URL filtering, SSL forward proxy, or NAT gateway traffic. So let's focus on north to south inbound traffic. So what we're gonna do, we're gonna connect to our client VM using the public IP of client VM through our SSH terminal. So this client VM has a client subnet associated with that. It has its own route table. In this route table, we are ensuring that anything incoming traffic goes to the firewall IP. 10.10.059 is our firewall IP address. And this firewall IP address is part of the firewall VCN subnet. If you look at the firewall subnet, you will see firewall subnet route entry. It has a route going outside through internet gateway. So that way, what's going to happen, if a traffic comes from internet, wants to talk to client VM IP directly, client VM route is pointing to the firewall. Firewall is saying go to internet gateway to go out, and the incoming will be internet gateway will have its own route table, which will say if you want to reach to client subnet, go via firewall first. So if you go to this client VM again, which we were looking, this is the firewall subnet, internet gateway, and internet gateway is its own route table. This route table will ensuring that if you want to reach to 10.10.1, which is the private IP of client, needs to traverse through the firewall. So why don't we go ahead and connect to the client VM. Alright, so at this point, what we're going to use, we're going to connect to client VM using the public IP. So use this public IP, go to the terminal, and you should be able to connect from outside. If you hit the IP address, you would see this, the private IP is 10.10.173. The only IP which is allowed is my public IP, because we have put a policy here on the firewall, the policy which is applied to the firewall level. My public IP can connect to client CIDR, which is 10.10.1 using my public IP. And if you wait for a minute, and so you should be able to see the traffic is getting hit to this firewall logs, which we'll see in a bit. You can filter those logs based on the rule. I'll come back to in a bit. So the goal was just to test out the workshop point of view. Inbound inspection is working fine. Similarly, if you want to reach to from north to south outbound, so if you want to reach to something outside, and if you want to see, since we already defined the decryption profile and rule and all, you should be able to reach from client to outside. So what we're gonna do, like let's just do a ping test, make sure that outbound allowed traffic is allowed. So we're gonna do ping so ping count to info.7.ch it's able to reach outside. So since it's able to reach outside, the SMP is working fine. The policy which is gonna hit is the rule client to outbound allow all traffic, which we saw earlier. If you're curious to know if it's hitting the right policy or not, you can do a log search on the traffic log. Earlier we were testing the my IP to client. As you can see, if you click on search icon here, you will be able to see traffic is hitting from my public IP to the client destination is 10.10.173 over SSH. We were able to reach inside, and it was hitting the rule which we wanted to hit the first time. Similarly, if you want to test out the recent one, you can test out the rule client to outbound all traffic. It should able to see the SMP traffic to this is the ping traffic which we initiated from client VM to the destination which we initiated. So you're able to see that in log traffic is also reflected here. So that covers north to south, inbound and outbound. Alright, so now let's take a look at the east to west intra VCN traffic. So what we're gonna do, we're gonna send a traffic from client to server, SSH or ICMP, and make sure that it goes to the firewall. Same goes for web subnet A to web subnet B, it goes to the firewall. For web subnet A and B, the idea would be the traffic needs to traverse through the DRG because we are using DRG to communicate between between VCNs. So that's all the routes needs to be there. So let's connect to the client VM first and do an ICMP traffic. So this is my client VM. I want to reach to server. It's able to, ICMP is blocked, which should be the case. I will show in a policy in a bit, and SSH should be allowed. Policy. So let's go back to your network firewall policy first. So if I see here, client to server VM allow SSH traffic is fine. So I am allowing from client to server sider. ICMP is fine, but SSH is fine and ICMP is blocked. So if you see here, ICMP is rejecting. So that's why we were not able to do an ICMP from client to server, but SSH is allowed. So the first ICMP should hit this policy, SSH should hit this policy. Same way, if a server A and server B wants to talk to each other, and we are going to do an ICMP, so ICMP should be this one traffic, and server B to server A, they want to do an allow SSH traffic. This should be the case here. Policy. So let's go back to your network firewall policy first. So if I see here, client to server VM allow SSH traffic is fine. So I am allowing from client to server sider. ICMP is fine, but SSH is fine and ICMP is blocked. So if you see here, ICMP is rejecting. So that's why we were not able to do an ICMP from client to server, but SSH is allowed. So the first ICMP should hit this policy, SSH should hit this policy. Same way, if a server A and server B wants to talk to each other, and we are going to do an ICMP, so ICMP should be this one traffic, and server B to server A, they want to do an allow SSH traffic. This should be the case here. Alright, so now connect to the server A VM. What we're going to do, we're going to do a ping and ICMP as well as SSH traffic from server A to server B. As I pointed out, server A, I have deployed a internet gateway into Spock VCN. That's not required, but in my case, just for easy way for me to connect, I deployed a VM into public subnet. So I'm gonna connect to this public VM. You should see this private IP associated with 10.20.133. in our case, we already defined the route rules at the subnet level to make sure it goes to the DRG, reaches to the firewall through the VCN ingress route table, and reaches back to the firewall through the DRG, and then reaches back to the server B. In our case, let's do a ping. You should be able to ping, as well as you should be able to do SSH based on the policy which we have defined. So if I look at my policy here, so before I look at my policy on OCI network firewall, so the policy which it should hit these two policy here, ICMP and server B to server A traffic which wants to reach it there and all, it can also hit that policy. If you're curious to know, you can ping from server B to server A. Ping should work. At the same time, it should hit the policy which I just showed. You can also query those policy from the logging which I mentioned here. So I'm not going to show every policy log, but you can follow the workshop to know more about it. Okay, so we have covered intra-VCN. Similarly, inter-VCN, the idea would be what we're going to do. We're going to do a ping from client to web server A and web server B. Depending on the policy which we configured, it should go through the firewall and the routes which you need. You can follow along the workshop. If you're curious, just to showcase, if I want to see from client, if you look at the client subnet route table, it will have a route pointing to the server. This is the server A or B CIDR, which is in the spoke. The idea would be like it needs to go to the firewall. And when you see the traffic, it exits from firewall subnet, it needs to have route via the DRG, because this is the spoke CIDR and the DRG. So what we have done here, to test the inter-VCN traffic, we have defined the policy. So if you see here, client wants to talk to server B, the traffic is rejecting. If a client wants to talk to server A, traffic is allowing. The similar way, like from spoke to firewall VCN, the traffic is allowed. So if you're curious to see, you can do inter-VCN traffic from one. So let me just go directly there and take you to the instance. So we already on the client PM. What we're going to do, we're going to do a ping to server B, make sure that it's being rejected. So it should be rejected. But if I'm into server A traffic, so let me pick the server A IP. If I do a ping to server A IP from the client, it should be allowed. Similarly, if I want to do a ping from server A to client, it's going to follow the path of DRG to reach to firewall and back to DRG, and it should be allowed. So this tells us, based on topology which we wanted to know, client can reach to server A, server B, and obviously depending on policy which you define, as well as servers sitting in the spoke, they can reach to client or server, even though like if you try to ping from server A to server sitting into firewall VCN, it should work, because we have defined the policy for that. So that tells us inter-VCN traffic also. Similarly, the next part which we want to focus on IPS and IDS traffic, just specific for client VM, we're going to test out, because client VM has a route via pointing to the firewall has the route pointing to internet gateway. We are using the internet gateway ingress routing capability. So to support that, what we have done here on the firewall policy, we have defined a policy which is specific to intrusion detection. So for example, if a client VM wants to talk to anything outside, is going to hit this policy. The first one, it's also going to hit only for in a certain URL, like only HTTP URL for InfoCern or ESPN, but this particular policy is going to hit for the intrusion detection. So the idea here would be, you're going to download a file. So let's connect to the client VM. So go to your client VM, try to download a malware. So this is the malware which we're going to try to download on the client VM. You should be able to download. The reason is because the policy is currently intrusion detection. If you modify the policy or have another rule just for prevention, you can choose that. You can modify the policy accordingly. That covers the IPS IDS part. If you want to modify the policy, you can do that. Similarly for forward proxy, so what we're going to test out, like before forward proxy, let's test out the URL filtering. So for the URL filtering, we have created a firewall policy specific to URL filtering is this one. So URL filtering is this one, URL filtering info7.com.ch or ESPN traffic. So if I do an wget espn.com, this traffic should go to the URL filtering. Similarly, there's an HTTP traffic. It should also go to the same policy. You can always go to the firewall logs. From the firewall log point of view, you can query those logs here. We were also doing this threat logs, IPS and IDS. You can also explore those logs from the log name here. And from there, you can find out what kind of the logs are hitting to the IDS and IPS. At the last, let's just quickly take a look at the SSL forward proxy. So SSL forward proxy, there is already an decryption rule. Everything is defined on our policy. The idea here is if a client wants to reach outside our HTTPS traffic, it should take that SSL forward proxy rule in picture, decryption rule, and the idea should be like if it wants to reach outside, can it download the page? If yes, it is hitting the right policy or not. So to test out SSL forward proxy, you can go to client VM and trying to download a file or HTTPS. And this file should be able to download it, and because it's following the decryption rule and the policy which you define at the firewall level. Similarly, the next task, which is around net gateway ingress routing. So what I have done in behind the scene, like I took care of updating the route entry at the firewall level. So if you are curious to see what I've done here, client's route table hasn't changed much because I'm still pointing to 002 firewall. But the firewall, when the traffic exits from the firewall level, what I've done here, like if I want to reach it outside, I'm using net gateway to go out. So it's going to use net gateway, and the return response from the net gateway is going to hit the net gateway route table. So in this case, the architecture will remain more or less same. The idea would be like you can have an additional gateway like service gateway, net gateway, but in our case, net gateway. So net gateway will have its own route table also. That will ensure the return traffic also goes to the same firewall and destined for client. So if you are here, all those LinkedIn page and all which you're trying to download is following the same path of, if you do espn.com again, it should be able to download the file. And it's hitting the required policy defined for net gateway, which you can also filter out from the logging. As you were looking at the traffic logs, you can also look at the threat logs. So what I did, like we were trying to download an malware 2 times. So you will be able to see the IDS like detection. So you will see the action alert, ICAR vulnerabilities from the source client VM. You were able to trying to download and all. If you had like prevention, you would see action reset here. So that covers the last task of similarly you can define the service gateway. If you want to support the ingress routing capability at the service gateway level, you can do that. In the end, if you choose to destroy the environment, you can do that like manually or using Terraform as per the workshop outline defined it here. So that pretty much concludes our workshop. So hopefully it was helpful. You can follow along the workshop outline which I mentioned, and if you have any open question, always can reach out on the network firewall live lab workshop helpline. Thank you.